Here we are in the IDE. I have created a normal Java project and it's called as multithreading. So the plan is that for the entire duration of this tutorial, I'll be using the same project and I'll be creating different packages inside the project to discuss the concepts of the multithreading. So in this particular section, we will be discussing about the sequential execution. So in order to demonstrate the code, let's create a class, call it a sequential execution demo. And here is the idea behind this particular class. I will be creating certain methods and the intent of this particular class is to showcase that in a normal Java program, the execution happens line by line and there is no jumping around from this part of the code to the other one. So let's get going. So to begin with, I'll create the main method, and in the main method, I will have two methods. Let's call those as demo1 and demo2, and let's create those two methods. I won't be doing anything fancy. I'll just create a normal for loop which will be iterating in certain range, and then it will print some message, and that's it. So let's copy this one and let's change the name, and here let's change the message as well. And now let's run the program. On running this is the outcome that we have. So first we were executing demo1 method. So the entirety of demo1 is executed, wherein it will be printing from 0 to 4 with this message, which is from demo1 plus I. So from demo1 0, from demo1 2 till 4, and likewise we have executed demo2, and in that case we print this message which is from demo2 and the ith number, which is from demo2 0 to from demo2 4. So what we see is that the execution happens line by line. So the main method is the first one to get started, and the first thing it sees is that we are invoking a method called as demo1. It goes there, it executes it, it comes back. Then the next line it says is that it's demo2. It goes to demo2, it executes it, and it comes back here, and then the execution terminates. So this is what we mean by the sequential execution. So in the context of multithreading, what we can understand is that each and every program is single threaded unless otherwise instructed. So here we just have a single thread, and that is the thread that is created by the JVM for the execution of this main method. And this could also be called as the parent thread or maybe the main thread. Now let's learn about the way in which we can create threads in Java. And the first way is to implement a runnable interface. So we will create a class, let's call it as Runnable thread example, and let's have a main method created. The way it works is that we will have to define some sort of class, and the class will implement a runnable interface. So let's do that. So let's call it as thread1, and it will implement the runnable interface. And the runnable interface has one method which we need to implement. So that's run method, and the logic is whatever we implement inside the run method, that is executed by this thread. So let's do that. So let's have a for loop which runs from I0 to I4, and it prints a message. Let's call it as thread1, and I would be the ith time it has been called. Now let's create another thread. Let's call it as thread2, which implements runnable, and let's implement the run method. And here as well we can run from I0 to I4, and let's print the message, call it as thread2 and I. So this is a way in which we can define the threads, and once the threads are created, they need to be somehow started. So in order to do that, what we can do is we can define a thread. Let's call it as 1, then new thread, and we can pass the class that we have created. So thread1, and likewise we can say thread2, new thread 2. And we have the handle for these two threads 1 and 2. So how do we start these threads? Well, we have a method called as start. So let's do that. So what happens is, once you call the start method, JVM will start these two threads and they are in the runnable state. So they could be either immediately running or they will have to wait because they don't have any CPU available at their disposal where they could go and run. So let's run this and see what is the outcome like. So what we see here is first thread 1 is running, then we have thread 2 running, but this may not be the case always. So in order to see a clear example, let's increment the number of times we are going to print this message. So let's increment it to 10 and let's do this to 15. Now let's run the program and see the outcome. So here is what we see. First we have thread 1 running and then thread 2 takes over. And then thread 1 is running and then thread 2 takes over. And so on and so forth. So once everything is executed, the execution will stop and the program will terminate. So what we are observing is, we have created two threads, we have started the threads, but there is no sequence in which they are executing. Rather, the thread has been created and it's available to be scheduled by the thread scheduler, and once the thread scheduler finds an available spot for a particular thread to be run on the CPU, it's assigned to the CPU and that's the time it's running. For the time when it does not have the access to the CPU, the thread will have to wait. And that is the reason we are seeing a back and forth execution pattern wherein first one thread will run for some time, then thread 2 will take over, and then thread 2 will wait for some time, and then thread 1 will take over. There is also a different way in which we can create a thread using the Runnable interface, and that is by making use of the anonymous inner classes. So let's create thread 3, then new thread 3, and what we can do is new Runnable, and let's print a similar kind of message. So I less than, let's say 15, I plus plus. The message could be thread 3 plus I, and we can do the same thing, which is 3.start, because 3 is the handle that we have given for this particular thread. One thing which you can observe is that this could be easily turned to a lambda. So let's do that. And here we have a much cleaner way of creating a thread using the Runnable interface. So all we need to do is, inside the lambda, we can provide the logic which needs to be executed by that particular thread. Now let's run it and see its outcome. So we can see thread 2 is running, then thread 1 is running, then thread 3 is running, and every thread gets some time of execution with the CPU, and eventually all the threads are executed and terminated. So this is how we can create threads in Java by implementing the Runnable interface. The other way of creating a thread in Java by extending the thread class with the help of extends keyword. Let's learn about the same. So let's create a class and let's call it as extends thread example. Let's create the main method. And now let's create the different threads. So let's call it as thread 1 extends thread class, and likewise we had to override the run method in the example of Runnable approach. We need to do something similar here as well. So let's do that. And we can have a for loop which runs from I as 0 to 9, prints a message. Let's copy this. Let's call this thread 2. Let's change the message as well. So we have created two threads, which is thread 1 and thread 2. Now we need to instantiate it. So let's call this as thread 1 and then new thread 1, then thread 2 and new thread 2. Please note that here we are directly creating the thread class. We are not passing this object inside the thread constructor like we were doing in the case of Runnable approach. So now once we have the handle for the threads, we can call .start on these two. Let's run this method and see the results. So what do we see? We have thread 1 running, then thread 2 takes over. Now again we have thread 1 and then thread 2 takes over. Finally everything is executed and the program gets terminated. So the basic idea remains the same. Once we call .start on these threads, they are in the runnable state, and based on the availability of the CPU, they will be submitted to one CPU and they could start with their execution. Now that we have seen both the approaches of creating a thread, one by implementing the runnable interface, other by extending the thread class, let's see which approach is better. So if we extend thread, then we cannot extend any other class. Usually it's a big disadvantage. However, a class may implement more than one interface. So while using the implements runnable approach, there is no restriction to extension of class now or in the future. So in most of the cases, runnable is a better approach to create a thread.